let's just say we don't want to put off until tomorrow what we can preserve today. What are our options? Well, as we saw before, NEDCC is a great place to go for optical scanning services, or if you prefer, I'm sure the folks at Berkeley will build your own optical transfer station. In terms of tactile options, the Archaeophone became the archival standard when introduced more than 20 years ago, I think now. Unfortunately, new Archaeophones are not being made at this time. That said, we have two new machines on the horizon, the immediate horizon, by the way, and their designers, John Levin and Nick Berg, are here to tell us about them. So we'll start with John Levin.
First, a point of information about me and an admission. I am a serious and passionate audiophile. I loved recorded sound, and I've spent most of my life listening to it critically and carefully. I've also listened to tens of thousands of acoustic recordings, most of them cylinders. And about 25 years ago, I started listening to that 1% that David was talking about. These are the earliest and most easily damaged cylinders, brown wax cylinders. And since then, I've listened to thousands of them, and I actually own thousands of them. When I first got interested in these recordings, I used the ubiquitous reproducer of the 1890s, the Edison Automatic, because it seemed to be the least destructive way to play them at that time. My logic was based on the economics of the coin slot operators that had to get at least 20 plays out of cylinders in order to just break even, and assuming they were keystoning, they probably got 40 plays out of them. And so that seemed to be a pretty good deal to me. But fairly quickly, I started to get an uneasy feeling about this because I realized that the wear that I was hearing was probably inflicted by the very same Edison Automatic reproducer. So, in search of better sound, and also to start transferring cylinders digitally, I obtained the ACT attachment, which some of you may know is now sold as an Edisonia. I think it's being sold. And I used it for many years. But I wasn't convinced that I was actually hearing everything in the grooves because of the Stanton 500 cartridge it used. And I was particularly concerned about its 5.8 grams of tracking force because, after all, I would never play an LP at that kind of tracking force. Around that time, I distracted myself by going to a movie called Inconvenient Truth, which is about a problem that actually is even more pressing than how to play cylinders optimally and non-destructively. I also spent some time and went to the sound lab at UCSB, where Professor Seubert was very kind in letting me access their equipment, and I experimented with their Archaeophone. When I first went there, I noticed Stanton cartridges again. Then I tried to play an 1894 cylinder that I'd brought with me. I set the tracking force to 2.5 grams, which I considered a pretty healthy weight even to play an LP. And the arm of the Archaeophone just sat there. It didn't move. The reason for this was an inconvenient truth, and it was the first of 4 inconvenient truths I had to address in order to play cylinders optimally using tactile technology. Fortunately, thanks to the enduring popularity of vinyl, cartridge technology has actually advanced quite a lot since the ARSC cylinder subcommittee first addressed the subject of tactile playback 15 years ago. And it has significantly improved since the Stanton 500 first appeared in 1960. To get back to that problem of the skipping Archaeophone, you have to look at this from the standpoint of the groove. Cylinder groove geometry is completely different from LP grooves. LP grooves are basically deep channels, and the values you're seeing here for the cylinder groove are in mils, that is thousandths of an inch. 1.1 mil is finer than human hair. If you have an iPhone with a retina display, it's about the size of 1 pixel. These grooves are so shallow, they're almost flat. And this is very inconvenient since the groove is supposed to hold the stylus in place. Accurate tracking this shallow channel requires an incredibly sensitive tone arm. The archaeophone arm simply had too much friction and too much mass to track it. Now, the solution for the archaeophone, and actually for the Edison automatic, was to simply force the stylus into the groove by adding weight and letting gravity do the rest. So when I tossed a 2.6 gram penny onto the shell of the archaeophone, it tracked fine. But 5 grams to get the best available technology to work, I just wanted to do better, and I actually wanted to find out what better looked like. Fast forwarding to the present, the result is CPS1. It's a late prototype, and you'll hear what it sounds like today. It uses a low mass, low inertia tone arm, and using conventional cartridges, it nominally tracks cylinders at about 2 grams. It plays 2 and 4 minute cylinders. You can play some odd size cylinders like 6-inch Columbias, Busy Bee cylinders. Speed is variable continuously from 80 to 230 RPM. Start-stop times are about a second, which is very important for people who buy lots of cylinders like me and also for production environments. But let's get back to that tracking force problem. And is 2 grams light enough? Well, to be clear, you're not really looking at tracking force. You're really talking about stylus pressure. Groove wear is a function of stylus pressure. And stylus pressure is defined by 2 parameters. One is tracking force, and the other is contact area. The 2 parameters are actually inversely proportional to each other. So the way to think about this is like in the snow. If you're wearing shoes, you might sink into the snow. But if you're wearing snowshoes, so you've got a larger contact area, your pressure is reduced and you can walk on top of the snow. Using the algorithms that were developed by the ARSC subcommittee, let's see what those tracking forces actually look like in terms of stylus pressure. There are actually a few inconvenient truths in this chart. If you look at the stats for the high-end LP cartridge, 1,350 milligrams per square mils. This is the stylus pressure that these cartridges are built for. Now if you go down to the Edison Model C and the Edison Automatic, these both track at stylus pressures that are too high for cylinders. We know that. But they're far below the stylus pressures that cartridges are built for. Now let's go down and look at the stylus pressure of the ACT Edisonia. Note that it's actually higher than the automatic. So that's inconvenient, particularly if you're relying on one of those rigs. And now look down at the wear test that Rebecca presented. This is for the cylinder that Jerry worked on, cylinder 4, with a stylus size of 7.5 mils and a tracking force of 4 grams. The stylus pressure is 23 milligrams per square mil. And we can use this measurement as a sort of benchmark based on the negligible wear that Rebecca measured. And remember this value because you're going to see it again as I go further into the presentation. The stylus pressure of CPS1 is even lower, so this is all starting to look good. But note that these low stylus pressures were achieved not only by reducing tracking force, but also by using a 7.5 mil stylus. This is the beginning of the next inconvenient truth. Stylus size is really important. A 7.5 mil stylus is actually too fat to track the narrow undulations at higher frequencies. When they're not tracked, they're not reproduced. The recording pioneers had a solution for this. They just increased the groove speed. And in so doing, the undulations spread out so higher frequencies could be tracked. Note, I'm saying higher, not highest. The only way to track these tighter undulations is with a more narrow stylus. But how narrow does it have to be? The cylinder subcommittee developed algorithms to calculate this based on various stylus geometries. Perhaps inadvertently, they only gave us the worst case scenario. That is, they based their numbers on the largest front-to-back stylus dimension. And when I say front-to-back, if this is your groove, this is front-to-back, not this, that's side-to-side. Anyway, the narrow tip of the stylus can track higher frequencies, albeit not at full modulation. Nevertheless, the following numbers, which are based on the subcommittee algorithms, illustrate the problem very well. An Edison Model C, or a Stanton 500, or any cartridge fitted with a 7.5 mil stylus front to back, tops out at 2300 hertz when playing a 120 RPM cylinder. Notice that that increases by almost 800 cycles on cylinders that are recorded at 160 RPM. More importantly, look at how the frequency response extends as you narrow the front-to-back dimensions of the stylus. You can actually get up to a frequency response up to 5,000 cycles. As I said before, this is the worst-case scenario. Because higher frequencies are rarely recorded at full modulation, the narrow portion of the stylus ball actually can resolve them. This extended frequency response can be audibly confirmed using a common 31-band graphic equalizer in conjunction with narrow ellipticals. And you actually heard this during Rebecca's presentation. The suite that was reproduced went up to about 9,000 cycles. So narrow ellipticals take us to the last inconvenient truth. These are some of the same stylus pressures you saw before, and here are the stylus pressures at more desirable stylus geometries at CPS1's 2 grams of tracking force. The inconvenient truth is that as you reduce stylus size to improve frequency response, you also increase stylus pressure. Now, this is very inconvenient indeed, and my guess is that in the past with circa 2000 cartridge technology and the Archeophone's tracking forces, that was sort of the last nail in the coffin of tactile playback. But remember, when I went to UCSB's Sound Lab, 2 things bothered me. Tracking was one, but the other was if low-end cartridges were adequate for cylinder playback. So now let's talk about cartridges. I've done a lot of work with the Soundsmith Company and its cartridge guru, Peter Lederman. We have learned that cartridges can be optimized to perform well at very low stylus pressures, and that better sounding cartridges, not surprisingly, yield better sounding transfers. But remember, based on my UCSB experience, these stylus pressures are too low for an Archeophone's arm. Working with Peter Lederman and also expert stylists in England, we developed the V-Trace cartridge for CPS1. At its core, actually, the V-Trace is one of the Soundsmith's high-end cartridges, standard stereo cartridge. We've customized it with a special cantilever assembly, made some other tweaks, and you can see them listed here. The V-Trace cartridge married to CPS1's tone arm enables tracking at 1.4 grams for most wax cylinders. So now let's go back and look at these numbers one last time. Again, for reference, here is the value from Rebecca's wear test, 23 milligrams per square mil. Underneath are the values for CPS1 tracking at 2 grams. Note the 8 by 4 mil stylus. This geometry is pretty much my daily driver for 2-minute cylinders. And look what happens when you go down to 1.4 grams. We're way below the stylus pressure that produced minimal wear in Rebecca's test. Improvements in sonic quality, while not subtle, are hard to hear without making A-B comparisons. It's like comparing 2 wines that have wine spectator ratings that are 5, 8 points apart. But hearing is believing. I'm about to play a cylinder that is in that 1% category David talked about. It's a real gem because it's got very explicit provenance. The announcer is Calvin Child, and the cylinder was made during his brief stint in November and December of 1896 at the Ohio Phonograph Company. The band, Brand's Concert Band, is led by Peter Brand, who shortly after this recording was made, founded the Cincinnati Symphony. I'm playing this with a V-Trace cartridge, with the 8x4 mil stylus, and it's tracking at 1.4 grams. And for those of you who might not be familiar with listening to a dry transfer like this, it's raw. It's an unrestored 120-year-old cylinder, and you're going to hear groove noise, you're going to hear wear, and it is slightly equalized with a graphic equalizer. Otherwise, it's basically unlimited sampling.
Selection from the Chimes of Normandy, played by Brahms Concert Band.
In conclusion, my parting comment to this audience is that, in my opinion, it's okay to transfer your cylinders.